Hi guys, and welcome to part 5 of the Interactive Fog tutorial series. So before we jump into this one today, I just want to say a big thank you to everyone that's supported this channel so far. We've hit over 400 subs now, which is amazing considering how terrible my upload schedule has been and the subpar content that's on this channel. But in terms of my upload schedule, I just want to apologise again for it taking so long to actually get this out. As I've said in the past, I don't have a huge amount of time to get some of this stuff done. And especially recently, I've got a new job and all sorts of things, and life's kind of got in the way a little bit. So I just want to say sorry for it taking so long to get this part out again. This one may be split into 2 separate parts as well, but if it is, then I'm going to be recording them both today, so you don't need to worry about having to wait for that. So we'll talk about now what we're actually going to look at in this part, and then we'll go on to actually implement all this stuff. So in terms of adding interaction to our fog, there's a few different ways that we could actually do this. We could use a field of particles, for example, or we could use a full fluid simulation if you really wanted to, which is now possible. But obviously we're not going to dive into that kind of thing in this. We're going to use a slightly more simple method where we're just going to capture a mask, and then we're going to use that mask to actually mask out some of the extinction of the fog in certain areas and then fade that back in over time. And we're also going to use this mask inside a ripple solver as well. And we'll have a look at how that's implemented a little bit later on. But first of all, we're just going to worry about how we're actually going to capture this mask to begin with. And we're going to do this by using another scene capture. And essentially what we're going to do is we're going to capture from underneath our fog volume here, and we're going to use the capture height that we've already used inside our other scene capture as well. So we're going to capture the height of objects from the underneath, and we're going to compare that against the height of our fog. And we do that inside a material here, this interaction material. And when we compare those, if the height of an actor is lower than the height of our fog, then our value is 1, otherwise it is 0. So this just creates a nice 0 to 1 mask, which tells us any areas where there are actors or meshes intersecting with our fog. And this is very simple for now. We can make this a little bit more complicated a bit further down the line, but for now we're just going to worry about having a 0 to 1 mask. And the first thing we're going to do is look at how we capture that mask. And it's very, very simple. So we'll go on to have a look at how we do that now. So to set this up, first off, we're just going to need to create a new material. I've already done this, and it's called Draw Interaction. Call this whatever you wish, but this is the material that's going to be actually taking in the 2 render targets and comparing them and outputting our mask. So just create a new material, and you could leave this blank for now. We'll worry about what's actually inside here in a minute. But first of all, we'll jump into the blueprint and actually set up the additional scene capture and a couple of the other things that we need as well. So to do this, you can see that we now have one down here at the bottom as well. All you need to do is select your height capture, and you just want to duplicate this because we want to keep exactly the same settings that we already have. We're using the same post-process material and everything like that. So you just want to duplicate this and call it interaction capture. Its position is set inside the construction script, if you remember, so you can just leave it in the same position. So just duplicate it and call it interaction capture. And then in our construction script, there's just a few things that we need to add. So at the start here, we just have our fog mid and our fog height capture RT. I think before this was just called fog height RT, but I've called it height capture RT now, just to differentiate it a little bit, because these 2 capture ones here are our capture targets for our scene captures here. So then we just need to create these 3 things here. We need to create a dynamic material instance of our interaction material here, and just call that interaction mid. You then want to create another render target of R32 again, and call this interaction capture RT, and this is the target for our interaction capture. And you then want to create another render target, which will be R16F, which is our interaction RT, and this will be the actual mask that we capture to. Now you may have seen this debug plane thing here. We'll look at this a little bit later on, so don't worry about that at the moment. In terms of anything else that's changed, we just need to add these 2 functions here as well. We won't worry about this one just yet because we need to create that material first, but our interaction capture setup is what's going to position our capture. And we've already done this for our height capture, if you remember. So we just need to duplicate this and call it interaction capture setup, as I have here. And if I open this, you can see that it's identical, except we've just changed a few things here. We've removed the capture height from the end of there, obviously. And then we need to make sure that we change the height capture out for our interaction capture. you want to change your rotation to be 180, 90 and 90. And you want to make sure that you're also subtracting half the volume size here, not adding it, so that we're now starting at the bottom and we're facing up and in the correct direction. The ortho width is exactly the same. You want to make sure you switch out your texture target to be the interaction capture RT, not the height capture RT. And you also want to drag off your show only actors and create a new array of variable and call this interaction actors. And you want to make this instance editable, and I've added it to the interaction category here, but again you can categorize and arrange any of this however you wish. But this just is a list of actors that our interaction capture can see. So this is essentially the actors that are going to interact with our fog. And you can see here, this list will appear at the top, and we can add any actors that are in the scene to this list. But if there's anything that's not already in the scene, such as a character, this character is here, but for example, there may be other characters that spawn in or objects that spawn in. So you want to add those as well. In terms of the characters, all we do is on begin play, we just loop over every character here, and we just add this to the list of show only components. So when you want to actually add an actor to this list, this is how you would do it. You just need to feed an actor in, and you just add it to the show only actor components here. So in this case, we're just doing it on begin play for all characters, as I said. But if you're spawning objects that you then want to interact as well, you'll need to call this function again and add them to that list. Then on the event tick, all we're doing here is we're just capturing the scene. Now you could do this using the capture every frame here, but we're going to optimize this a little bit later on, so we're not capturing every single frame. So we have that turned off for now, and we're just doing it on tick at the moment. And we're then just drawing that interaction mid material to our interaction render target here as well. So if we take a look at that material now, we'll create that, and then we'll come back into the construction script here, and we'll set up any variables that we need for that. So if we open up this material, yours will be blank, and this is how it should look. At the moment, I've got it to opaque just to show off something in a second, but we'll have this as translucent or masked. There's a few different ways that we can do this, but for now, we'll have this as opaque, and then we'll come and switch this up in a minute. But basically all we're doing here is we're taking in that interaction capture render target, which holds the world height of any objects captured from below, and we're also taking in the height of our fog. And we're doing this by taking our height capture RT. So this will currently only work if you're using the height capture method for the fog, because we're doing this inside of a render target, so we can't use distance fields and that kind of thing. So that's just something to note. But essentially we're just getting our floor height and adding our fog height. So this here gives us the height at the top of our fog, and this here gives us the height at the bottom of any objects. So we're just comparing these two, and we're just saying if the height of any of these objects is higher than the top of our fog, then we're printing a value of 0. If it is equal to or lower than, so if we're touching or we're intersecting with it, then we print a value of 1. And that's all we're doing here. As I said, we'll come back and we'll switch this up in a minute, but we'll leave it as opaque just for now, just so that we can actually visualize this in a minute. And if we come back into our construction script, I've just created another function that just sets those variables on that material there. So you just take your interaction mid and just make sure that you set your interaction capture RT, your height capture RT, and your fog height to the appropriate variables as I have here. And that's everything that you actually need to then capture that mask. So that is currently capturing every frame. But of course, if we're in here and we're not seeing anything because we're not actually plugging any of that into our fog material or anything at this stage. That will just come a little bit later on. We're just worried about setting it up here. But it'd be nice to actually visualize this so that we can actually see that it's working. And that's where that debug plane comes in that I spoke about before. So if I scroll back down here, all we're doing here is we're just adding a static mesh component. Now, I can stress this isn't necessary, of course, but you want to do this just to make sure that you've actually done everything correctly so that we can visualize it. So we're just adding a static mesh component, which is just the plane, and we're setting its transform using these settings here, just to position it slightly off from our volume, just so that we can see it. And then we create a dynamic material instance of a very simple debug material that just takes in a texture parameter and outputs that onto the plane. So it just takes a texture in and draws that to the plane essentially. And that's all that does. So if I just actually add this here and compile, you can see that we now have a plane here as well. And then in our event graph, if we actually want to see anything on that plane, we need to also draw our interaction mid material here to that debug render target that's being displayed on that plane as well. So if I do that and then we jump in, we can now see where that sphere is interacting. We can see that it's printing a value of 1, and also where our character is here as well. So we can actually see that interaction mask. Now, we can't keep this as an opaque material for several reasons. One of them being that when we plug this into the ripple solver, which we'll do shortly, this needs to be translucent so that we're not overwriting what's currently in the ripple solver. So if we actually change this up now, we'll change this to translucent for now. We could change this to additive or masked or whichever we wish, but translucent is the one that we're going to be working with. And this means that we can now actually just plug a value of 1 into our emissive color, and we can plug this if into our opacity instead. And now if we do that and we take a look, you'll see that we're actually leaving a trail here, which is something that we're going to use later on to mask out the extinction of our fog, and we're going to fade out that trail over time as well. So that's everything set up in terms of actually capturing the mask now. So we'll look at integrating this into the ripple solver and visualizing that using the debug plane too. And then depending on how long this has been, we'll jump in and actually start to add some of this into the main material itself. But before we do that, because the main material is actually getting quite complex now, we're going to move this project over into 427 or UE5, depending on which you're using. Either one works fine, because there's a new feature which will actually allow us to tidy up all of our materials a hell of a lot, and it makes things so much neater. It's a very, very good addition to the engine. Excuse me. So we'll add the ripple solver now, and then, as I said, depending how long it's been, we might actually go in and tidy up that material, ready to actually then integrate the ripple solver and everything into the fog material itself. When it comes to actually integrating our ripple solver, this is in the form of a component that I've actually created ahead of time. So I just want to stress, we're not actually going to be creating the ripple solver component in this tutorial series, because it's a sort of a video by itself, or a series of videos by itself. But I am going to upload the project files as I always do, and I'll actually upload this ripple solver folder here that contains the component and the two materials separately, and I'll put both the links for those in the description, so you can download the folder which just has the UAsset files in here, and you can then drop that into your project files, into your project directory, sorry, or you can download the whole project and migrate it across, however works for you. But I will upload it so that you can download this ripple solver component, because we will need that for this next part here. But as I said, I'm sorry that we're not going to cover how to create that, but it's its own thing entirely. So we'll look at how to actually just integrate that one once you've downloaded it into the blueprint itself. So once you do actually have that ripple solver, it's very easy to actually integrate into the blueprint, because I've made it as simple as possible to actually use by creating a few sort of intrinsic functions and so on. So all we need to do is add a component here, and we just type in ripple solver, and we add our ripple solver component. As you can see, we have some settings on the side here. We're going to leave these alone just for now, but we will come back and tweak these a bit later on when we're tweaking the visuals and things like that of our fog. But for now, we'll just worry about actually integrating this and getting it running and visualizing this. So if we add our ripple solver component, we then drag off it and get a reference. We can then just run a function called initialize solver, and you want to do this in your construction script right at the end of your construction script, and that will initialize, that will run all the setup that we need to actually initialize that solver. And then all we need to do is just do a couple of things inside the event graph as well. So in the event graph, on our begin play, once we've completed our loop, or we could do this before if we wish, we just need another reference to our solver component, and we just want to start that solver. There's also an option to stop the solver too, if you want to, but we won't worry about doing that at the moment. We'll worry about that when we come to optimize things a bit later. So now we have our solver initialized, and it is now running when we begin play. So we now just need to inject our interaction into this. And again, this is very easy. All we need to do is, again, get a reference and type draw interaction. And this will take in a material, and it will inject that interaction into the ripple solver itself. And in this case, we just want our interaction mid, and we'll just plug that into there. And we now have our interaction being injected into our ripple solver component. However, we want to be able to visualize this using our debug plane again. So what we're going to do here is, again, just drag off the component, and we'll just get a reference to the actual solver material itself inside here, and we'll plug this into our debug RT here. So we're now just printing that ripple solver to our debug RT instead. And that should be everything that you need to do to actually get this ripple solver set up and running. So if I click play, we should see, as we do, that we now have ripples here. And as you can see, these look obviously more like water ripples, not something that you'd see in fog, but this is something that will change when we come and play with those settings a little bit later. So that's everything that you need to do to actually get this working. In this part, we'll now go on and just tidy up our material function a little bit, because if you remember, it's got kind of crazy in there and we need to add a load more stuff. So we're actually going to use a new feature which has come with 427 and also in UE5. And we're going to be leveraging that to tidy things up a little bit and make it a bit easier. So in the next part, we can then come in and actually just add all of this into the material itself. So to do this, we are going to have to migrate the project over. So from this next cut onwards, I am going to be using 427, but you can also use UE5, as I said before, if you wish. You also don't have to do this, of course. This won't actually change the overall workflow of what we're doing. It will just make things sort of a hell of a lot neater and a lot easier to work with. So I definitely recommend upgrading the project to 427 at least when it comes to do this. So I'm going to go ahead and do that now, and then we'll come back in and tidy some of that stuff up. So now that we've upgraded the project to 427 or to UE5, as I said, the choice is up to you. They both have this feature. We can actually start to tidy up this fog function a little bit so that it becomes a lot neater and a lot easier to actually start to add this interaction stuff, as well as just when we actually look at it, it's just a lot easier to see what's going on. So you may not actually know this feature even exists. It's kind of hard to find, to be fair. It was in the release notes, but I couldn't figure it out at first, and I had to Google it, and it took me a few minutes to find out. But basically, you can see that we have this huge sort of spider graph here, and this output here is going to many inputs, which leads us to use loads of reroute nodes and all sorts of stuff. And if you're sort of looking at something at this end of the graph, you have absolutely no idea where some of these pins are actually coming from. So there's a way that we can actually now tidy this stuff up. We also can't duplicate a function input. If you do that, it just creates a new input. So we can't sort of duplicate this all over the place and have this plugged in. But what we can do now is create essentially local variables in the material graph, or declarated or reroute declaration nodes, as they're actually called here. So if you drag off the pin and type in reroute, you see that there is now something called a named reroute declaration node. And essentially what this does, if you click on it, you can just give this a name, and then you can call this anywhere else in the graph multiple times. So you're just saving this off to a named variable, basically, and then we can just pull this variable wherever we want. So we'll do this for our world position to begin with, and we'll just call this world position, and we'll just leave the color as whatever it is here. And you can see now that anywhere that this is plugged in, if we go here, we have this named reroutes option, and we can just get our world position, and we'll just put this into here, and we'll replace anywhere that actually has this world position as an input. So if we go through our graph and do this, we can see that obviously things will start to get a lot neater. And especially as we go along here, for example, we now no longer need all these huge chains of reroute nodes and everything like that. It just makes things so much more simpler, or so much more simple, sorry, should I say. And so we just need to make sure that we replace all of these, and there's one up here as well. And that should be everything that was world position before. So we can now just start to actually delete some of this mess that's left in here. And you can see it's made things a hell of a lot neater already. And so what we're going to do is we're actually going to chunk some of this stuff off. So we now have our world position here, and we'll just comment this and we'll just call it world position. And so we know where that is. You can also change the color of these things as well if you want. So we could change this to a red. So we'll just do that. We'll just make it red instead. So we'll just take the blue out of here. Now that is world position. So we'll do the same thing here for the base shape too. So we just have a single output from our base shape. So we'll just save this off as a name declaration as well. And we'll just call this base shape. And now anywhere that has the base shape plugged into it. So here, for example, we've copied world position there. Sorry, not base shape. We just take it from here. So base shape multiplied by this instead, and now you can see that this is just sort of a separate chunk that we can move out the way. This is all already commented up, but it just makes things a little bit easier to read. And again, we'll do the same thing with this here. So we'll take this off as a reroute node as well, and we'll call this our height fall off. So we've got a height fall off here, and then we just want to get that here, height fall off, multiply by base shape, and we can move this over here now. And you'll see that this will just be the height fall off in the true, and you can see that it's made things, again, a lot simpler. So we can sort of move this off over here now as well if we want, and just have all these things as sort of separate chunks. And this is something that's really, really useful. As I've said, it just makes things so much easier to work with. And now that you have this, you can see this is something that's a lot easier to read. So we're just seeing that we're actually just multiplying our base shape here by our height fall off based on this switch. And then we're integrating some of our noise and stuff here as well. And so now we can go ahead and we can also add our interaction stuff in here in the next part in sort of a separate chunk. And then we can just plug this into our height fall off and our extinction, wherever else we need it. And it just makes things so much easier to read. So that's pretty much everything in terms of this. We don't need to simplify things down too much, otherwise then it does start to get sort of complicated again. Just try and chunk things off sort of where it makes sense, just so that it does make things easier to read, and so that you're not just, you know, taking absolutely everything into a variable, because that's not necessary. For now, this is all we need. So with that out of the way, I think we'll wrap this one up here, and the next part we'll actually go and we'll integrate the ripple solver and the mask into this function as well, and we'll start to actually visualize some of those things that we've generated inside of our blueprint as well. So thank you guys for watching. I really appreciate all the support, and stay tuned. The next part will be out very shortly. I'm going to try and record that today as well. So hopefully I'll see you in the next one.